Hello, everyone. It's an honor to present one of my PhD papers here. So this paper is co-authored with my supervisors, and one of them, Ivan Diaz-Rainey, and who is currently in Australia, and Dominda sitting here. And next slide. Okay, so yeah, this is my outline, basically. Research question, key findings, introduction, literature review, data methodology, result highlight, and then I'll conclude. So this research, this paper is motivated by two strands of literature. The first one, good. Yeah, the first one basically is a strand of literature that's on carbon premium, and recently there is a debate between Aswani and Bolton's paper, and I personally find it very amusing to read. It's more like so that's part of my literature based on. Basically, they argue that there is a positive relationship between emissions and the return. And then there's a second strand of literature that is on basically kind of related to the quality of disclosed emissions. So, and they found that, yeah, so one literature found that there's an inconsistent third-party emission estimation, and then a couple other literature find that there's a self-selection bias for the voluntarily disclosed emissions. So I combined these two together, and I identified there's a literature gap here that is, does the market actually distinguish the information uncertainty risk between estimation and mandatory voluntary disclosure? Because it seems that from the carbon premium paper, a lot of them, they just discuss the emission, but they didn't really take out the effect, the disclosure effect, different types of emissions, basically. So my question is, can the carbon premium and information uncertainty of voluntary and mandatory emissions explain, and as well as the estimated emissions, explain the cross-sectional returns? So my key findings are, so first of all, I did find the voluntary emissions kind of positively related to the returns. But then when I proxied emission risk with emission intensity, I found some sort of the almost like, contrasting result, that is voluntary emissions, emission intensities negatively relate to the returns, and mandatory also negatively relate to the returns. And then when it comes to the different types of emissions, I found that the voluntary and mandatory disclosure positively relate to stock returns. And then when it's related to the investment strategy, I found that there's a significant excess premium between the estimated and mandatory emissions. And it's all focused on scope 1 and 2 emissions. So the scope 3 emissions is excluded here. So why that's important? Because now there has been a rising demand for better climate disclosures. And this will serve as a sort of to inform policymaking. So perhaps we should regulate the emission estimation and voluntary disclosure more. And so how do we do that? So basically 3 sort of steps. The first is to conduct this disclosure choice logic model, and I'll explain the rationale behind that later, and then run an OLS regression, and then Farmer Macbeth cross-sectional regressions. And the contribution lies in, first, I identify, overlook significant information on certain risk price in the cross-section, and the enrich literature on carbon premium and mandatory disclosure, and provide policy implication and investment strategies. So the literature, we know that there's been traditional asset pricing literature, so the farmer French, the risk factors, and then now recently there have been a sort of identification of a carbon premium, carbon risk. So it's kind of add on to traditional asset pricing literature. So, and then For Australia, Australia serves an interesting context because there has been many signs showing that Australia business are likely already experiencing material climate-related risks, and that's channeled from this different types of risk here. So that leads to my hypothesis one, that is there is a positive relationship between the emissions risk and the stock returns. And the second level is the second hypothesis related to the literature on the different types of emissions. So Australia, they have this the threshold based that's the mandatory disclosure mandate, disclosure kind of mandate. So that sort of basically split the emission sample into two types. So there's the estimated emissions. Well, it's basically refinitive icons data. So there's estimated emission, the voluntary emissions, and there will be mandatory emissions. So I argue that when there is disclosure, so when it's there's a mandate there. So when the emissions are mandatory disclosed, that means there's more certainty related to that emissions. So so for the mandatory, if there's a more certainty, that means it's probably lower risk. So lower risk, probably that means a lower required rate of return. So that leads to my second hypothesis, that's a positive relationship between the mandate or voluntary disclose. So it's that decision has a positive effect or positive related to the returns on the left-hand side. And my third hypothesis is related to so it's more like a difference between the pricing of the estimated emissions and the voluntary emissions and the mandatory emissions. So so my third hypothesis is that relative to estimated emissions, voluntary emissions and mandatory emissions should be associated with a lower carbon premium, just because there's more certainty related to mandatory emissions, and still relatively also more certainty related to the voluntary emissions. And my data was from refinitive icon, and then so yeah, all the standard sort of variables and a lot of controls to control for the firm's characteristics. So my step one, the methodology is a pre-estimation analysis, and I ran this disclosure choice logic model, and to compute the inverse Mills ratio, and use that calculated Mills ratio to my real, like my sort of main analysis to control for the rationale. Let me explain the rationale behind it. Is because of the ASX market, although there are many firms and many observations, but the number of emissions data. So basically, you will see a lot of missing values, missing values for the emissions data. So I ran this regression to control for that sort of missingness of the emissions data. So basically I ran that and then calculate the inverse Mills ratio, and extract that, plug that inverse Mills ratio into my the methodology that's for hypothesis testing, and that's in the OLS models. And so it's also stepwise, as you can tell. So the second equation is just my baseline model, and the third equation, I added the voluntary dummy and mandatory dummy in, and so you see IMR there. That's to control for the missingness of the emission data. And the fourth equation is I added two interaction terms. That's voluntary emissions and mandatory and emissions. So step three is so that's a methodology related to the investment strategy application. So I ran the Farmer Macbeth cross-sectional regression, and then so I extract the carbon premium, the beta 1, and for each type of emissions, related to each type of emissions. So, and then I compute the differences in beta 1 between each pair and sort of derive the excess premium. And then I use that in my step 5, I test the statistical significance of the each excess premium. And as you can see, so left-hand side is excess premium, and right-hand side are the conventional risk factors from a French risk factors. And what I'm actually expecting to see here, what I'm trying to see is that, well, is this excess premium have already been captured by the traditional risk factors or not? If it has already been captured, then it will be a redundant, basically, risk factors. But if not, then, well, there's some sort of evidence here saying that, okay, so the uncertainty risk is somewhat, can be a useful explainer for the cross-sectional return. And so I'm just listing some result highlights here, and that's so this is summary statistics. That's for the summary statistics for the subsamples, different subsamples for the sample that has estimated emissions, for sample that has voluntary emissions, and sample for that has mandatory emissions, and can see that somewhat there is some from here, it seems that, and also from here you can see that the emission, when it's mandatory emission, seems to have a so basically the mandatory disclosing firms tend to have a higher return, and the returns in decimals and monthly. This is the monthly data set, and then associated with higher returns compared to other subsamples, and the highest, bigger size, and the higher leverage, and the PPE fixed asset. And so this is the table that's presenting carbon premium among estimated mandatory voluntary emissions. So this is, I have 12 legs here. As you can see that, so related to the first hypothesis, that's a relationship between emissions and returns, and it appears that at least from, if you look at the first row, that's a log S1, S2, that actually tells the information about estimated emissions. And the voluntary and mandatory dummies, they are the disclosure effect, basically. And then there's the different, this two here are kind of giving the information about the differential sort of difference in between the estimated emissions and voluntary emissions, and estimated emission between estimated emission and mandatory emissions. And so from here, you see at least the estimated emissions, it seems there is not a significant, so there's not a significant relationship, which is kind of, so different from a lot of like Bolton's paper saying that there has been a widespread sort of evidence saying that there's a positive relation, at least not in for the estimated emission here in Australian context. And then from the voluntary mandatory disclosure, you see there's a positive relationship. So it does seem that when there is that means when a firm discloses either mandatory or voluntarily, it does inject some sort of assurance, like certainty, and therefore lower risk, therefore lower rate required rate of return. And so when it come here, the difference, we'll see that relative, the voluntary one relative to the estimated emission, it has a higher, like positive, which is, a bit, interesting. So, and the mandatory emissions relative to the estimated emissions, it doesn't show any significant sign. So the same that there isn't a significant difference between mandatory and the estimated emissions. So, but if you combine this voluntary and the baseline, the estimated emission there, you will see that voluntary emissions, that seems to positively relate to the premium. Yeah. So, and then this is the sort of the using a different proxy, that's the intensity. The result relates to the second hypothesis is the same. So it's a positive relationship between the disclosure effect and the returns. And then whereas here, when I proxy the emission risk with by the intensity, the result is showing that it's negative. But this is consistent with what we hypothesized earlier that, you know, relative to estimated emissions, voluntary disclosed emissions should be lower because it gives, you know, the information versus is better, meaning more certainty, lower risk, therefore lower required rate of return. So this is the last step. That's for investment strategy. And what we found is that for the excess premium between the estimated emission and inventory emission, the constant is consistently significant. That means that this is a sort of you know, it cannot be, so the excess premium cannot be explained by the conventional Froment-French risk factors. Whereas these are not significant for the estimated emission, voluntary emissions, and the difference between voluntary emission and mandatory emission. So it that seems that the risk, the uncertainty risk embedded in the estimated emission is sort of being asked for a higher return. And well, but when it comes to intensities, well, the result shows difference. So it's a bit interesting as well. So I'll just wrap up. So related to my first hypothesis, the voluntary emissions positive relate to stock returns, although at different legs. But intensity gives something that's opposite story. It could be that telling different story. And then second hypothesis is all consistent, either using emissions or intensity, and that is it has a positive effect to positive relate to the stock returns. And third hypothesis that I found that there's been a significant asset premium between estimated and mandatory emissions, suggesting that investor can profit from such an investment strategy, that is to long the estimating firms, the firms that are estimating the emissions, and short the firms that mandate to disclose their emissions. So that's all. Thank you.